Hello, everybody. Welcome back. Today we're doing Chapter 7, Section 7.8, looking at word problems involving. This is our final example for the chapter. So we're going to look at the question. We're going to write draw a diagram to help us out. It's kind of like a physics question, I guess. Little velocity equals distance over time will be involved. It says at noon a sailboat leaves a harbor on Vancouver Island and travels due west at 10 kilometers per hour. 3 hours after, another sailboat leaves the same harbor and travels due south. Means we'll go with a vertical line down at 15 kilometers. So it's 3 hours later. At what time to the nearest minute will the sailboats be 40 kilometers apart? Draw a diagram of scale. So if we're looking 40 kilometers apart, we need distance. All right. So I'm going to draw a diagram. I'm going to explain where some of this information is coming from. Okay. So if we have this diagram here, everything has to be in terms of distance. So remember, we have, you may recall from grade 10, or what you're doing now, we have velocity, or of course, speed is equal to distance over time. All right? Yeah, I'm not going to get particular to the physics terms that you folks are accustomed to if you're taking physics, but for the sake of argument, V is equal to D over T. So we want to get everything in terms of D because we were told the distance between these two are 40 kilometers, right? So due west at 10 kilometers per hour. So that means if we rearrange this formula, as you folks have done in the past in your classes, we would have distance is equal to velocity multiplied by time, right? We multiply both sides by T. So the velocity is 10 meters per second multiplied by the time. And we put time as T, so that's what we're going to let the variables equal, right? Okay. So we'll let T be the number of hours it will take for the sailboats to be 40 kilometers apart. All right. And it says 3 hours later. So well, again, velocity equals distance over time. So the velocity is 15. The time is going to be a little different. We'll have to subtract 3 from it because it's going to be the time it takes for them to be 40 kilometers apart. So if we use T here, then let's say the time was 2 hours. Or sorry, not 2 hours, 4 hours. Well, that means it would have taken this boat here, it left 3 hours later, so the time would be 1 hour. So it would be 4 minus 3 to give you the 1, right? The difference of the 3. So that's why you're subtracting the 3. A lot of people get tangled up with that. Okay? And that is really the hardest part of to draw that diagram and create it. Now, obviously, we're doing quadratics. So what we're going to do is we're going to create a quadratic equation for that. Obviously, we have this right angle triangle. So you may remember back to middle school when you first did Pythagorean theorem. So we're going to do that. So we'll write down our formula. C squared equals A squared plus B squared. C is the side opposite the right angle, the hypotenuse, right? So the hypotenuse in this case is 40. A can be either the side. So I'm going to make the side 10t, all right, so 10t, so make sure that 10t squared, not just the t, all right, and then this 15t minus 3, I'm going to simplify that up 3 up here, so if that's 15 bracket t minus 3, to make it easier, I'm going to do the distributive property and make that 45t minus 45, okay, so that's going to be your b side, 15t minus 45, and that's all squared, all right, so let's simplify this. So 10t squared is going to be 10 squared is 100 and square the t if we get 100t squared. Okay, here we go to distributive property, a little more complicated, not a big deal though. So that would mean we would have 15t minus 45 multiplied by 15t minus 45, right? Expanding that, okay, obviously. So we do the distributive property. So 15t times 15t is 225 t squared. Sorry, 15t times 15t is 225 t squared. 45 times 15, we get 675. So it's minus 675t. Oh, sorry. Minus 675t, do it again, minus 675t, and 45 times 45, that gives us 2025, oh, sorry, positive 2025, right? Negative times negative is positive. Those two like terms in the middle, we're going to clean all this up. Oh, I could have did the 40 squared long ago, I'm sorry. 1600, obviously, 40 squared is 1600. All right, we're going to take the 16 over to the other side, so we're going to subtract it from both sides. I'm going to go down here, and we're going to clean up all the like terms. So we have these two are like terms at the beginning here, so that'll give us 325t, right? 100 plus 225, so 325t. The two t's come together, and that'll give us 1350, so minus 1350t. And add these together, and that'll give us 425. Okay? So once we have the 425, I kind of recognize that these are divisible by 5, so I take the 325 and I divide it by 5, and I get 65. So I'm even going to try 25. It looks like they're all, because if this ends in 50, and this ends in 25, you could actually factor out a 25, or divide through by a 25 because it's equal to 0, whatever works for you. But since we like factoring so much, I'll factor out a 25 from all the terms. That leaves us with 13t squared minus, and we take the 1350, divide that by 25, and that'll give us 54 minus 54t, and take the 425, divide that by 25, and that would be obviously 17. All right, so a little easier to deal with here. You only got to use that as your for your quadratic formula, or you can just graph it. It doesn't make a difference to me how you get the t values. So let's do that next. So like this won't factor, it's the best you can do, but you could use a quadratic formula, or you could just graph it. What I'm going to do is I'll graph it on the graphing technology, the graphing calculator. I'll bring that up here for you. What I'm going to do is I'm going to put in y equals, it's 13t squared, so we'll use x, 13t minus, and what do we have? We had 54x plus 17. I'll graph it, all right, and you can see where it's coming through here. So second function calculate the zeros because that's what we're interested in. All right, we'll come down here. Oh, hit enter for one time, hit enter for a second time. That'll give us negative 0.343. Do the same thing. Second function calc, 0. Right, and we'll go over to the second x-intercept. Hit enter, bring it above, hit enter for the third time, we get 3.81. Okay? So, I'll snap a picture of that. Alright. So, using the graphing technology, we guess t equal to, and it was 0.343 seconds, and we also got t equal to 3 decimal, and I have it here. I'll just pop that diagram. There it is. Right, I can only show one of them, but it was both values. They were done the same way, and that would be 8.1. Okay, using the graphing technology. Again, you can use a quadratic formula that we used in previous lessons, but if it doesn't say what to use, doesn't say algebraically, I'm going with, obviously, my graphing technology. Okay, so that doesn't answer the question, though. All right, so this one here is too small. Obviously, this is what's called an inadmissible value, because if you put t in up here, for time and you subtract 3, then you're going to get a negative time, which can't be the case. So obviously the second one there is, so right here we cross this out, we say it's inadmissible. Now remember, inadmissible means it still is a solution, but it's not going to work for our question, okay? It won't work for our particular. So the time is equal to 3.81 seconds. Or sorry, that was hours. My apologies. Let me fix that. It was time in hours. My apologies. So that was in hours. So we want to get that to the minute, they said. So what we have to do is we have to convert. So what we'll do is we'll convert that. Okay. And we know that in 1 hour, there's 60 minutes. 60 minutes. The hours divide. The hours divide. So we multiply the 3.81 by 60, and we get 228 minutes, 6 minutes. All right, so it's set to the nearest minutes, or 86 minutes, which is equal to 3 hours and 49 minutes, I guess. 49 minutes, because the decimal 6 is round up, right? Yeah, actually some seconds there, all right? Another way to do that is you can pull the 3 off it, and you can only know that that's 3 hours, that's 3 whole hours, and the decimal 8 multiplied by the 60, and that would give you the 49. You can do that, right? Whatever works for you. So if I do the decimal 8 one and multiply it by 60, that gives me 49 minutes, or whatever you want to do, right? So it's whatever works for you. So if you read the question, it says they leave at noon, so we want to know at what time to the nearest minute. So that means that to answer the question, at what time to the nearest minute will the sailboat be 40 minutes apart? So we'll answer the question. The sailboats will be 40 kilometers apart at 3:49 p.m. Because it was noon, which is 12 p.m., so I just added the 3 to that. So like, for example, let's say it was they left at 1:30, or 1 o'clock, whatever the case would be. Let's say they left at 1 p.m., then it would be 4:49. You would just add the hours and the time to that. All right? So that is it for chapter 7. It is complete. There's a few questions go along with that on page 437, numbers 2 through 8. So that's it. We're all finished. Hope you're enjoying the videos, and we're headed to chapter 2 next. Thanks for watching.